Containers make for an interesting debugging experience. Long gone are the days of SSHing into a running server and tailing a log file. In large-scale Docker deployments that use a scheduler to dynamically place Docker containers, you don't always know where your containers are running. Fortunately, Docker allows you to configure application logging to output to central logging systems like FluentD or Splunk. If you do have access to your Docker host, there are a number of ways you can debug your container, and we'll discuss those in this chapter. The first way is to simply see which containers are running. We've used the docker ps command numerous times already. This just lists all the running containers, and as you can see, I have the Nginx web server running. Stopped containers do not show up in this output. To show any stopped containers, just run docker ps-a. And we now see both our running Nginx container and a stopped MySQL container. Another useful flag for docker ps is -l, which will show the last run Docker container. Let's start up a Redis container in the background and test it out. And now with docker ps-l, the only container we see is Redis because it was the last one that we started. Easy enough. What if we want to see the output of our Redis container? We can use docker logs to see the current logging output. And this just shows the most current logs and exits. Similar to the tail command, we can add -f to docker logs to follow the logs. Using -f will follow the logs in the terminal until we press Ctrl-C. What if we want to get the local IP address of a Docker container? We can use docker inspect, which returns a large JSON payload of information about a container. That's a lot of information. We can use the format flag to extract just the data we care about from the JSON. This feature uses the Go programming language's template support. The dot notation represents the JSON properties, where network settings is a top-level nested object containing the field IP address. Any fields in the JSON are passed to this template as the model, so we can access any of them using the dot notation. Let's take a look at the JSON. And we can see that network settings is a top-level attribute. Below, we can see IP address. And there's our IP address in the output. There's a lot of information we can grab about our container using Docker commands. But every once in a while, you need to be able to get into the container and look around. You can enter a container by running it using the -i and the -t flags that we saw earlier. If we use the command bin bash, we'll start an interactive shell inside a container. So now we're inside the Ubuntu container. And we've already seen this in action in earlier lessons, and while it's neat, a Docker container running an interactive shell isn't usually terribly useful. More likely, there will be another primary process running in the container, which means that bin bash can't be the main process. So if a container is already running a process as PID1, how can you get inside the container to look around? A Redis container is running Redis as the primary process, and the container is already running. You can use docker exec to run a secondary process in a running container. This secondary process does not shut down the container when it exits like the PID1 process does. This is a great way to shell into a running container and look around. Let's try. This will run a secondary interactive shell in the Redis container. And now we're inside the Redis container. If we run ps-A, we should see all the processes running. And you can see here that the Redis server is PID1, as we expected, and we are PID13, and our ps command is PID18. Now that we're inside the container, we can debug the main process just like we would if it were running on a regular server and we had just SSH'd in. There's lots of features that Docker offers to give us insight on what's happening inside of our containers. But in production, we'd likely leverage other tools like centralized logging and metrics reporting to make debugging our Docker containers easier. And now that we've discussed the basics of Docker containers, we will move on to Docker images in the next chapter.